What's up? I'm Vin, and I'm going to go through the August 2024 Algebra 2 Regents, and I'll leave a link to a copy of this test in the description below. Now let's get started. So first we're going to go through the Part 1 multiple choice, and there's 24 questions here. Each question is worth 2 credits. Question 1, a grocery store owner wonders how many customers bring reusable bags to the store. An employee stands at the store entrance for 2 hours and counts the number of people bringing in reusable bags. This type of study is best classified as. So for this question, the most important sentence is right here. An employee stands at the store entrance for 2 hours and counts the number of people bringing in reusable bags. So this person is just making an observation. This is an observational study. Okay, so this is going to be our solution. It's not a survey because they're not actually asking these customers questions. It's not an experiment because they're not modifying the environment in any way. And it's not a census because we're not accessing any data that already exists. Okay, a census is way more formal than an observation. So it's not choice 1, definitely choice 3. Question 2, the graph of y equals 2 to the x minus 4 is positive on which interval? So for this one, I would go to the y equals and I would type in the function 2 to the x power. So we have 2, we hit the up arrow here. We type in our x, and now we get out of the exponent and we write our minus 4. And then we press graph, and here's a graph of our function. So now that we have a graph of the function, if we want to look for where the graph is positive, we want to look for where is the graph above the x-axis. Okay, so we're looking for when is the graph above the x-axis. And if we look at this graph here, notice at x equals 2, the graph reaches a height of 0. Okay, that's when the graph is on the x-axis. And if we look to the right, notice this part of the graph is above the x-axis. So this occurs when x is greater than 2. When x is greater than 2, the y values are greater than 0. But how do we write this in interval notation? X is greater than 2 is true when we are talking about x values that go from 2 to infinity. Okay, so when x is on the interval from 2 to infinity, the graph is positive. Choice 2 is our answer. Question 3, Tim deposits $300 into a savings account and the annual interest rate is 2.7% and compounds monthly. He uses the equation given here to determine how much money A he will have after T years. Which equation is equivalent to Tim's equation? So for this one here, there's one exponent property that we really have to know. We have to know that when you take A to the B and you raise it to the C power, you could say this is equal to A to the B times C. And then we look at this equation that we're starting with here. And if we take Tim's equation and we actually simplify this part, this will help us get to the correct answer. So we go over to the calculator and we'll type in 1 plus, and then we have 0.027 divided by 12. So I'm going to press alpha y equals enter, and I'm going to write 0.027, and we're dividing by 12. I can just use the division sign, but just in case you don't know that alpha y equals enter trick, it's just a nice way to pull up a blank fraction, especially when you have to type in something complicated. So now we press enter, and this is going to be the base of our exponent. So now we're going to rewrite Tim's equation. We have A equals 300 times the highlighted stuff simplified to 1.00225. And if we look, so far this answer choice is jumping out at me. So 1 is a really strong contender. But let's just see. Instead of saying to the 12t power, you see how this property of exponents is being applied, but we're starting with an exponent in product form, and we're going backwards and expressing it this way. So the base is being rewritten like this, and then we could say this is being raised to the 12, and then the whole thing is being raised to the t power. So this is definitely equivalent to what we started with. Now, another close answer here, well, we could just run through the other answer choices and see why they're no good. The problem with this one is that the base does not match. Okay, we need a base of 1.00225 if we have an exponent of 12t. So this one here is out. And this one is no good because we cannot simply just ignore the 1 that's attached here. People might think, oh, if I raise 1 to any power, it's just 1. So surely choice 3 has to be correct. But no, that's not how you deal with these type of expressions. I can't say that 1 plus 0.027 over 12 to the 12t. You cannot just do something like this. You cannot say 1 to the 12t plus this decimal over here being divided by 12, 0.027 to the 12t. This is not equivalent to what we started with, okay? So this is no good. And then here, let's see what happened here. That's basically exactly what they're doing is 1 to the 12t plus this to the 12t, and then multiplied by 300 to the, yeah, this one's way off. So choice 1 is definitely our answer. Question 4, which equation is true for all real values of x? So all of these start off the same, x to the 4 plus x. And we're seeing which one of these is going to be a correct way to break down this polynomial here. Well, one thing we could do is polynomial division. We could think about what would be a root of x to the 4th plus x if we set this equal to 0. And this would be true if x was equal to -1. So if x equals -1 is a root, then that tells us after this that x plus 1 is a factor. Okay, so x plus 1 is a factor. So looking at the answer choices, I'm going to eliminate these two here and see that it's going to be one of the first two. I know that this is not possible because, for one, if I square this, I'm going to have an x to the 4th and an x squared, and I'm going to have some middle terms, but this one doesn't end with x squared, so that's how I know this one is definitely out. And this one, we can't say that x equals 1 is a root. X equals -1 would be a root of this. So now I'm going to divide the polynomial by x plus 1. And for this, what we could do is we could use synthetic division. So we have our polynomial here. We have x to the 4th power. So I'll express this as x to the 4th plus 0x to the 3rd plus 0x squared plus x. So we have 1x and then plus 0 at the end. So here, if I write out the coefficients, we have 1, 0, 0, 1, 0. And I run through the process here. The root that comes from a factor of x plus 1 is -1. And now I could start the process. So I bring down the 1. -1 times 1 is -1. And when we add, 0 plus -1 is -1. We multiply these two, we get +1. 0 plus 1 is 1. And now we keep repeating the process. -1 times 1 is going to give us -1. If we add these two, we get 0. And then finally, -1 times 0 is 0. We have no remainder. But now when we write this out, x to the 4th plus x, the factor is x plus 1. And these tell us the coefficients of our leftover term here, or the term that's going to divide into x to the 4th plus x. So since we started with x to the 4th, we're going to be bumping down to x to the 3rd. So we have x to the 3rd minus 1x squared plus 1x, and I could say plus 0 at the end, or I could just stop here. So I'm looking for x to the 3rd minus x squared plus x, and this is going to match up with choice 1. Now, of course, we could just go to the y equals of the calculator, and we could type in, we have x to the 4th plus x on the left side of the equal sign. And now the right side of the equal sign, we could just type in the y2 spot. So let's see if choice 1 is definitely good. So we have x plus 1 in parentheses times x to the 3rd. And then we have minus x squared. And we have plus x. And we press graph. And notice that the graphs overlap completely. If we press second graph and go to the table, the y values match for every x. If I were to type in one of the wrong answers, like let's say I type in choice 2. Let's see what happens if we find the wrong answer by mistake. So here we just delete all this stuff out. So let me just get rid of all this extra. So we have x to the 3rd plus x times x plus 1. If I press graph here, notice the graphs do not overlap completely. So this is not the correct answer. And we could also eliminate the other answer choices this same way. So choice 1 is definitely correct. Question 5, the solution of this equation is, and for something like this, we could just type right in the calculator. So the left side, I'm going to write alpha y equals enter to pull up a blank fraction, and we have x over x plus 3. And then I hit the right arrow, we write plus. I'm going to press alpha y equals enter again to pull up another fraction, and we have 2 over x minus 4. And now the right side, I'm going to type in the y2 spot. So we have alpha y equals enter, 2x plus 27. And then for the denominator, we have x squared minus x minus 12. Okay, we could go ahead and press graph. And this might be a little bit tricky to see where the graphs intersect, although I'm seeing this point right here. But what we could do is we press second graph, we go to the table, and notice that everything's in fraction form. So I'm going to press mode, and I'm going to go down to answers and switch it from auto to decimal. It just makes the table look nicer. So now I'm going to go through the x value answer choices. So at -3, we have an error. Okay, that means that x value is not a solution here. And the reason being, if we plug in -3 here, -3 plus 3 is 0. And division by 0 is going to make this undefined. So we can't have -3 as an answer. -7, notice that the y values do not match. So -7 is not an answer. If we go to x equals +3, notice the y values do not match. So now we go to x equals 7 and notice that the answers do in fact match. So if you just want to use the calculator here, you're going to get choice 4, and choice 4 is definitely correct. So our solution here is going to be x equals 7 because this is where the graphs intersect. But of course, we should know how to do this algebraically. But for the multiple choice, just know you don't have to show the work. But for the free response, you'd actually have to show the work here. So for something like this, if I'm doing this algebraically, I'm thinking of each denominator. And this one I factor to x minus 4 times x plus 3 because -4 plus 3 gives us -1, the coefficient of x, and -4 times 3 gives us -12. Usually what they're going to do is they're going to make the factors of the quadratic match the factors of the other denominators in the rational equation. So then what we do from here is we could multiply everything by the greatest common factor. But one thing I want to point out is that x is not allowed to equal any value that makes a denominator equal to 0. So notice x equals -3 would make this first fraction's denominator equal to 0. And if I plugged in x equals 4 to the second fraction here, we would have a 0 denominator. So I like to say what x can't be before I start doing any algebra. So now we can work this out. So what we want to do is we want to multiply by the least common denominator. And the least common denominator here would be x minus 4 times x plus 3. So this is one way we could handle this question. And I know this is the least common denominator because this quadratic has both of those factors. And if we were to multiply this one by x plus 3, it would have matching factors with this. And if we multiplied this denominator by x minus 4, we would have matching factors with this one as well. So that's the least amount of multiplying we'd have to do to get them all to match. So now let's multiply. We're going to multiply everything by x minus 4 times x plus 3. And one way to communicate this is I could put the entire equation like this in parentheses. So I would have x times x minus 4 times x plus 3, and my first fraction is over x plus 3. Okay, so that's the denominator of my first fraction. Then I have plus 2 times x minus 4 times x plus 3 over x minus 4. And then for the last fraction here, we have 2x plus 27. And we're multiplying this numerator by x minus 4 times x plus 3. And this is all over the quadratic here factors to x minus 4, x plus 3. So what's going to happen here is the denominators are going to all disappear. Notice x plus 3 over x plus 3 cancels. X minus 4 over x minus 4 cancels. And then both of these factors cancel out. So now we could write the leftovers. We have x times x minus 4. And if I do the algebra here, x times x is x squared. And then x times minus 4 is minus 4x. And then we have plus. We're left with 2 times x plus 3. So if I do 2 times x, I get 2x. 2 times 3, I get 6. And on the right side, this is equal to, we're left with 2x plus 27. So now from here, what we're going to do is we're going to get this quadratic with all terms on the left side. So what we have here is negative 4x plus 2x is going to make minus 2x. So I have x squared minus 2x plus 6 is equal to 2x plus 27. So now we'll solve this. We're going to go minus 2x on both sides. And we'll go minus 27 on both sides. So this is what we're going to do. And now what we have, 2x minus 2x cancels, as well as 27 minus 27. This is all equal to 0. And now from here, what we have is x squared minus 4x. And when we do 6 minus 27, that gives us minus 21. Okay, 6 minus 27 is negative 21. And now we could factor this. What two numbers have a sum of negative 4 and a product of negative 21? We would have negative 7 and positive 3. Okay, because negative 7 plus 3 is negative 4. Negative 7 times 3 is negative 21. And the root we get from x minus 7 equals 0 is x equals positive 7. If we plugged in x equals 7, 7 minus 7 is 0. And that would make this equation true. And if we set x plus 3 equal to 0, that gives us x equals negative 3. But once again, we had to reject x equals negative 3 because that makes the equation undefined. So this one here gets rejected. X equals 7 is definitely correct. Choice 4 is definitely our answer. Question 6, the cost in dollars of a single ride fare in the New York City subway in the years since 1904 is listed in the table below. Which equation best models the cost of a single ride fare based on these data? So for this one, we're going to press stats, edit, and we're going to go to this table here, and we're going to type in the x and y values. So the x values, I'll type in L1s. We have 0, 49, 72, and I'll just type in the rest. So now that we've got everything typed in, we want to know what type of equation would be best here, because we could do an exponential regression, a linear, or a log regression. So for questions like this, what I like to do is I press second Y to pull up the stats plot, and then I press enter to plot the points that we have in the table. So I'm going to switch this to on if it's not already switched there. And now when we press graph, I'm going to press zoom 6 just to put the graph back to normal. Notice that we can't really see what's going on, and the reason behind that, it's based on the table here that our x values are going from 0 to 111, and our y values are going from 0 to 2.75. So I'm going to go to the window and adjust things accordingly. I'll go from 0 to, I'll go out to 120 in the x direction. And then for the y direction, I'll start at 0 and I'll go up to, let's say 3. That's a little bit more than 2.75. And we press graph, and this is clearly looking like exponential increase here. So when I have to run the regression, I'm going to use an exponential regression. I press stats, calculate, and then the exponential regression, I press up, and you can see it's at option 0 here. So I press 0, and I keep pressing enter all the way through here, and I get these values here. So right away, it's looking like choice 1. And now if I want to plot that equation in my y1 spot, watch what happens. We have 0.0375, and we're multiplying by 1.0392 to the x power. So we have this, we press graph, and notice this curve is pretty close to these points here. If I were to do a linear regression instead, if I press stats, calculate linear regression, then that would bring me to, let's see what we get. We would get exactly choice 3. Choice 3 is a very dangerous bear trap. If we were to actually graph this, we go to the y equals, and we have 0.0234 times x, and then minus we have 0.487. If we graph this line, watch what happens with this line. Notice that it does go near some of the points, but it doesn't follow the points as nicely as this blue curve here. So choice 1 is our best answer. So remember, the graph in blue we could model with the equation y equals 0.0375 times 1.0392 to the x power. So choice 1 is the best equation to model this data. Question 7, which expression is equivalent to this one? And for the previous question, I used synthetic division. So here I'll show polynomial division. So I'm going to write the fraction bar like this. And we have 6x to the 4th plus 4x to the 3rd plus x plus 200. But what I'm going to do is I'm going to put a 0x squared since there's no x squared term. I'm going to put a 0 in front. And then I'll write plus x plus 200. You don't have to do this, but I find that this helps students stay accurate when they're doing this process. So now we're dividing all of this by x plus 2. So we could start the process here, and we're going to start by dividing the leading terms. So I'm doing 6x to the 4th divided by x, and that's going to give us 6x to the 3rd power. And I look here and notice that we have 6x squared at the start. So these two answer choices right away are gone. So just being able to start this process, you'll be able to narrow it down to just two answer choices. So now here I distribute. I do 6x to the 3rd times x is 6x to the 4th, and I have 6x to the 3rd times 2 is 12x to the 3rd. And now this is the part where if people mess up, like this is the most common place they mess up. You have to subtract this. So you could put parentheses and then minus, or you could just change the sign of everything. So if I have a plus 6x to the 4th, I just put a minus here. And if I have a plus 12x to the 3rd, I put a minus here. And now I combine all this stuff. So these terms will cancel out. And then we have 4 minus 12 is minus 8. So I have minus 8x to the 3rd and then I bring down the 0x squared, and I start this process all over again. So I'm going to focus now on the new leading term, which is minus 8x to the third. So I do minus 8x to the third divided by x is minus 8x squared. And from this part, now we have enough information to say it's got to be choice 4. Okay, because notice that we have a minus 8x squared, not the 16 here. The most common mistake, once again, is that people don't write a minus here and they do 4 plus 12 is 16. So just be careful. Choice 3 is a very dangerous bear trap. So now from here, we could just write out the rest. We have minus 8x squared times x is minus 8x to the third. And then minus 8x squared times 2 is going to give us minus 16x squared. And then we'll continue this process again. So once we do this, once again, we're subtracting, so we change the sign of everything. I could say minus minus, or I could just say plus and then plus. So these terms cancel. 0 plus 16 is 16, so we have 16x squared. We bring down the x, and now we have plus x here, and once again, we just continue this process. So I just want to see it through, just in case you use this process in the free response. So now let's continue. We have 16x squared divided by x is 16x. We have plus 16x, and now we multiply, we have 16x squared, and then 16x times 2 is going to give us 32x. So we have plus 32x, and remember, we change the sign of everything. So we go minus here and minus here. These terms cancel. 1x minus 32x is minus 31x, and now we bring down the 200. So we're almost done. So we have plus 200, and now from here, finally, we do this process one more time. So we're going to do negative 31x divided by x is minus 31. And now we multiply, we have minus 31x. And then we're doing minus 31 times 2 is minus 62. And then finally, we just do the subtraction here. So we're subtracting this binomial. And when we subtract, the signs are going to change. These terms cancel. 200 plus 62 is 262. And this is our remainder. So up here, I would write plus 262, but we are dividing by x plus 2. So that's how we know choice 4 is definitely our answer. But remember, if you really don't want to do this by hand, you can use the calculator. So I could press alpha y equals enter, and I could start by writing the original expression. The only disadvantage here is that if we do it this way, we have to type all the way to the end until we get choice 4. So if I type in choice 4, I'll be able to see that our answer definitely checks out. So I'm going to press graph, and here I can't actually see anything, but if I press second graph and go to the table, notice that the y values match for each value of x. And the reason I can't see the table is because the y values go way up here. So if I were to make my y maximum, let's say something like 1,000, then I'll be able to see more of what's going on. So you see there's the graph of the original, and here's the answer choice overlapping completely. So choice 4 is definitely good. Question 8, we're going to solve this equation for x. So we have 6 times 2 to the x plus 4, and this is equal to 36. So for this one, we could divide both sides by 6 first. That's going to make this a little simpler. So what we have now is 2 to the x plus 4 is equal to 36 over 6 is equal to 6. And then looking at all the answer choices, they all have natural log in them. So that tells us to take the natural log of both sides. So we have natural log of the left equals natural log of the right side. And now this is the property that we want to use. If we have any log, let's say I use natural log of a to the b power, I could bring the exponent in front and attach it by multiplication. So that's what I want to do here. I'm going to take the x plus 4, that's in the exponent inside the log, I'm going to bring it to the front. So we're going to have in the next line, x plus 4 times natural log 2 is equal to natural log 6. And from here, I'm going to divide both sides by natural log 2. So we divide both sides by natural log 2, and now we have x plus 4 equals natural log 6 over natural log 2. And then to solve for x, just subtract 4 on both sides. And this tells us that x is equal to ln 6 over ln 2, and then minus 4. So this is going to match up with choice 4. Now just be very careful here. Don't go, oh, natural log 6 over natural log 2. 6 divided by 2 is 3, so choice 3. Choice 3 is a very dangerous bear trap, okay? So just make sure you are not doing something like this. Remember, the only division that you're really allowed to deal with logs, the properties, is when you have something like, let's say, natural log of 6 divided by 2, then I could say something like natural log of 3 on the inside, but this I could also call natural log of 6 minus natural log of 2. Anytime you have division inside of a single log, then you could separate it into 2 logs attached by subtraction. But it's tempting, but please don't do something like this like they did in choice 3. Question 9, the asymptote of the graph of f of x equals 5 log of x plus 4 is, and for this one, what we could do, since we have a linear factor on the inside, is we could just set the inside to be equal to 0. So if we set x plus 4 equal to 0, this is true when x is equal to negative 4. So this tells us our vertical asymptote is going to be at x equals negative 4. If we were looking for the domain, we need the inside of a log to be positive. I set x plus 4 to be greater than 0. And this tells us that all values of x greater than negative 4 would be the domain of our function after I do minus 4 on both sides. So this would be if I needed the domain, but we just need the vertical asymptote. But we could graph this just to see that it matches up. So we'll go over to the y equals and we'll type in 5 log of x plus 4. And let's see what we have on the graph here. So we have this graph here. I'm going to press zoom 6 to put it back to normal. And here's our graph. Now, some people might look at this and say, oh, wait a minute. How do I know it's not, let's say, y equals? Well, y equals, if you forget if they're vertical or horizontal, let's say I type in y equals 6. Notice that this line is not an asymptote. The graph is actually going to collide with that red line. If I were to bring out my x-axis, let's say I go out to 40, then we could see here that the graph eventually does go over the line like this. Okay, so something like y equals is not going to be an asymptote. Same thing if I were to do y equals 5. If I were to use that line, notice that this is not going to be an asymptote. An asymptote is a line that the graph approaches but doesn't touch. X equals 4, the problem with that is that it goes through the graph. So that's why here x equals negative 4, you can imagine if I drop down a vertical line like this, the graph is going to be getting closer and closer and closer, but without touching. So choice 2 is definitely our answer. Question 10, the probability of having math homework is 1 out of 3, and the probability of having English homework is 1 out of 7. The probability of having math homework or having English homework is 9 out of 21. What is the probability of having math homework and having English homework? For questions like this, what I like to do is draw it out. So I'm going to draw out a Venn diagram, and I'm going to label this one capital M, and I'll label this one capital E. And then I'll put an X, Y, and Z here. And what we could say then is that the probability of having math homework is equal to X plus Y. X represents when we just have math homework. Y represents when we have math and English homework. And then Z represents when we have just English homework. So now I'm going to say for probability of English homework, that's going to be equal to Y plus Z. And now we could fill in the blanks. So the probability of having math homework is 1 out of 3. So I'm going to set X plus Y equal to 1 over 3. And then we have the probability of having English homework is 1 over 7. So that's going to let us say Y plus Z, or I could say Z plus Y is equal to 1 over 7. And then next we have the probability of having math homework or having English homework is 9 out of 21. So for this statement, if we read it very carefully, if we're talking about the probability of having math or English homework, then what we think about is we could either have just math, just English, or we could have both math and English. So that would be X plus Y plus Z. And this we're going to set equal to 9 over 21. So from here, there's a few ways we could go forward, but our ultimate goal is to solve for the probability of having math and English homework. So we're looking for the variable Y here. So now we could just start solving these equations. So to solve for the variable Y, I'm looking at this big equation here. It's the most complicated one, but I notice there's an X plus Y right here. And we know from over here that X plus Y equals 1/3. So I could just make a substitution and say 1/3 plus Z is equal to 9 over 21. And for this, I could just do minus 1/3 on both sides. And then the calculator will tell us what Z is equal to. So you could do that subtraction by hand if you want to make your elementary school teachers proud. Or you could do 9 over 21 and then minus 1 over 3. And you're going to get a decimal, but then you just press math, enter, enter, and it turns your answer into a fraction. So this tells us that Z is equal to 2 over 21. But remember, our goal is to solve for the variable y. So what I could do is I could plug into this equation for z, and that'll tell us what y is. So we have z plus y, so we have 2 over 21 plus y is equal to 1 over 7. And for this one, I'll just go ahead and find common denominators. So I'm going to multiply by 3 over 3, and that gives us 2 over 21 plus y equals 3 over 21. And now from here, to solve for y, we subtract by this on both sides. So I'm just going to separate here so we don't have overlapping work. So we're doing minus 2 over 21 on both sides. And on the left side, these terms cancel, and now we have y equals 3 minus 2 is 1, and our denominator is 21. So here's the value of y, and that's the probability of having math and English homework. Question 11, we want to find the solution set of this equation here. And for this one, we could honestly just plug in. So let's say I plug in something like x equals -1. That would give me -1 minus 1 equals the square root of 2 times -1 plus 6. And this gives us -2 is equal to -2 plus 6 gives us 4, but the square root of 4 is not equal to -2. The square root of 4 is equal to +2. So x equals -1 is no good. We would have to reject this, which would eliminate this answer choice and this one. So then the last thing to check is to see if x equals 5 is a solution. So we plug in, we have 5 minus 1 equals the square root of 2 times 5 plus 6. And now we have 4 equals the square root of 10 plus 6 is 16. And this is definitely true. The square root of 16 equals 4. So x equals 5 is a solution. So choice 2 is definitely our answer. Question 12, given x is greater than 0, the expression here is equivalent to, and for this one, we have to know a few properties of exponents. We have to know that a to the b to the c power is a to the b times c. We have to know that a to the -b, so I'll just write it like this. So we have a to the -b, this is equal to 1 over a to the positive b power. I could also say that something like 1 over a to the -b is equal to a to the positive b power like this. Okay, so this is another way of saying this rule. And then I also need to know that when I have something like a to the b over c, this is equal to the c root of a to the b power. Or I could say a to the b over c is equal to the c root of a, all of this being raised to the b power. So these are just some rules that we need to be able to go through this question. So the first one I would use is the exponent rule over here with the negative exponents. And this I could rewrite as x to the second power, all being raised to the -3/4. And then from here, what I want to do is I want to apply this rule. I have a power to a power, so I could just multiply. So I'm going to do 2 times -3/4. But just know when you multiply a whole number by a fraction like this, you just have to multiply the whole number by the numerator. So this is going to give us x to the -6 over 4. And then from here, what we could do is reduce. We could divide the top and bottom by 2 for this fraction, and this tells us we have x to the -3/2. But notice none of the answer choices are in negative exponent form. They're in radical form, so we're going to have to transform this. So now I want to apply this negative exponent rule again. So we have 1 over x to the 3/2 power like this. And then from here, what we're going to do is we're going to rewrite this as 1 over, and we're using this definition here for rational exponents. We have power over root. Okay, so since the exponents in this form are in the form power over root, we could say that, don't say the 2 root. The 2 root is really the square root. So we have the square root of x to the 3rd power. And then from here, it can be a little tricky in terms of how do we deal with this. But what we can do is we could either apply this rule here, or we could just split this term up. So there's options from this part. If you want to use this rule, then what you could say is, we could say that this is 1 over the square root of x all to the 3rd power like this. And then if you have 1 over square root x to the 3rd, that's square root x, square root x, square root x, then these terms combine to make 1 over x square root of x. Okay, so this is going to match up with choice 2. If at this step you would rather go a different route, you could also say that this is 1 over the square root of x squared times x. And then there's another property to know, radical AB is equal to radical A radical B. So then I could break this up into 1 over radical x squared times radical x. But then here I could say this is now equal to 1 over The square root of x squared is x when x is greater than 0. So then this would also give me a matching answer. That's a very sneaky detail. Just know that in general, the square root of x squared is equal to the absolute value of x, or we'll commonly say that square root of x squared is plus or minus x. But when x is greater than 0, we could just go ahead and say the square root of x squared is x. But either way here, we're getting choice 2. Question 13, the graph of which function has a period of 3? So for this one, if you know the general form for a sine function, something in the form of y equals sine of bx and then plus c at the end, if you know what each of these terms mean, then this question is not too bad. So a represents the amplitude. So this part over here is going to represent the amplitude. And I'll just abbreviate that with AMP. The b term here represents the frequency. And then the c term at the end is the midline. So for a question like this, if we're looking for the period, which doesn't show up here, we can use this equation though to find the period. The period is equal to 2 pi divided by the frequency. So I'll say 2 pi divided by the b term, where the b term is the frequency. So what I'm looking for, if I want to have a period equal to 3, then I'm going to say 3 equals 2 pi divided by my b term. Now, if your algebra is really sharp and you really know here that you could just swap these, then you'll say the b term is going to be equal to 2 pi over 3. Okay, if you do enough of these questions, you know you could just do the swap. But otherwise, what you do is just call this 3 over 1, and you could cross multiply, and you're going to get 3 times b is equal to 2 pi times 1, which is 2 pi. And then from here, we just divide both sides by 3, and that tells us that b is equal to 2 pi over 3. And out of all the answer choices, the only one that has a coefficient of x of 2 pi over 3 is choice 1. Question 14, which graph could represent a 4th degree polynomial function with a positive leading coefficient, 2 real zeros, and 2 imaginary zeros? For this question, we could focus on this part and think about what does it mean in terms of a graph. If we have 2 real zeros and 2 imaginary zeros, this means that we have exactly 2 x-intercepts. Okay, because the real zeros, the 2 of them, are the locations where the graph crosses the x-axis. So right away, I could eliminate these 2 answer choices because notice that these graphs have 4 real zeros. Okay, they have 1, 2, 3, 4 real zeros each. But these graphs only have 2 real zeros. That's 2 points where the graph crosses the x-axis, 2 x-intercepts. So now that we have this out of the way, let's think about the other part. They told us that we have a 4th degree polynomial function with a positive leading coefficient. So think about what does that do if our function starts off in the form of y equals, let's say, x to the 4th. So we have a positive coefficient here, let's say of positive 1. If we start off with one that looks like this, negative x to the 4th, then I'm thinking of kind of like a parabola, but a little bit more narrow that's facing this way, it's opening downward. So that would be a graph that looks something like this, that it's going to be dropping down, okay? But what we're dealing with is just x to the 4th, something in this form. Then we're going to have something that looks something like this at the ends, okay? So that's how I know it's going to be choice 1 because of the end behavior. This part guarantees then that as x goes to infinity, the y value should be going to infinity, okay? That's what the positive leading coefficient will do to the graph. Whereas in choice 3, this one is no good because as x goes to infinity, as we go all the way to the right, the y values are dropping, the y values are going towards minus infinity, okay? So if we had a negative leading coefficient, then choice 3 would be good. But if I just made up a function on the spot, let's say I did y equals x to the 4th and then minus something like, let's say, 16. So something like this is a difference of 2 squares. I could factor that to x squared plus 4 times x squared minus 4. This one here has 2 imaginary roots, okay, or 2 imaginary zeros. And this one has 2 real zeros, okay? So I just try to create one right on the spot. That'll work, and this one here would work. This would have 2 real zeros and 2 imaginary. Now, I know this one is not symmetric. It's not even. We don't have symmetry over the y-axis, but it does resemble the end behavior. So this one here is a reasonable graph to think about so that you could choose this answer choice and eliminate choice 3. Question 5, given I is the imaginary unit, which expression is equivalent to 5i times 2x plus 3i minus x times the square root of negative 9? So for this one, we have to know when we take the square root of -1, we get 1i like this, or just I. So I'm going to keep that in mind as we do this question. So we have 5i times 2x. I'm doing 5 times 2 is 10, and then I have x times I. And then we do 5i times 3i. That's going to give us 15 when we do 5 times 3, and then I times I is I squared. So this is another thing we're going to have to deal with. I squared, if I square both sides of this equation, that's going to break the radical, and we'll have I squared equals -1. So that's going to be important in a moment. And now we have minus x, and think of this as the square root of -1 times the square root of 9. All I did here was just use this property of radicals. When we have radical AB, that's radical A times radical B. So now we could simplify a bit. This is going to be equal to 10xi plus 15i squared we could replace with -1. And then we have minus x. The square root of -1, this piece is equal to I. So I'll just box these off so we see these equations are all separate. So the square root of -1, I'm just going to replace with I, and the square root of 9 is equal to 3. So I know this looks a little bit jumbled here, but we are going to rearrange things in the next part. So we have this is now equal to 10xi. 15 times -1 is -15, and then we have minus 3xi. And now these are like terms. I have 10xi minus 3xi. That's going to make 7xi, and then I have minus 15. But we're looking for the answer choice in the form of a plus bi. So they're going to flip these and say -15 plus 7xi. And when we scan the answer choices, we'll see this matches choice 4. Question 16, what is the focus of the parabola with this equation here? So for these questions, what I like to do is just really think about the concept of what a parabola is. So a parabola is in this shape. It has a vertex, a turning point, and the parabola is the set of all points that are equidistant from a focus, which is a point, and a directrix, which is a line. So I just imagine the directrix down here like this. So this is our line, and any point on the parabola we call xy. The distance from that point to the focus is equal to the distance from that point to the directrix. Okay, so that's the concept of what a parabola actually is. So how this helps us is that if we could get the quadratic equation in the form of y equals a times x minus h squared plus k, that allows us, if we identify the vertex of this parabola, we could start to imagine where the focus and directrix is going to be. Now, another thing I want to point out is if the parabola is facing this way, if it's opening downwards, then the directrix is above and the focus is below. Okay, so we'd have this, this, and this. So that's just something to keep in mind for this question. So now I'm going to do the algebra to get this equation in this vertex form over here. So I'm going to start with, we have 8 times y plus 2 equals x plus 5 squared. And I'm going to start by dividing both sides by 8. Okay, so 8 over 8 cancels. And now we have y plus 2 equals, and instead of saying over 8, I'm going to say 1/8 times x plus 5 squared. And then to solve for y, we just go minus 2 on both sides. And now here's our equation in vertex form. We have 1/8 times x plus 5 squared, and then minus 2. So with just this equation, we could actually answer the question. So the vertex is at the point hk. So our vertex is going to be at the point -5, -2. Notice that the x value of the vertex, so in general, the vertex is the point hk, that the term h has a minus in front. So we take the opposite of the number in front of x. So we're going to have -5 for the x coordinate, but then the y coordinate just matches directly. So we have the y coordinate is -2. So now I'm just going to go ahead and sketch something over here. We have -5, -2, and here is our vertex. But let's think about what's going on in this question. We have a parabola with a positive coefficient in front of the x squared. So this is going to be a smiling parabola like this. It's going to be opening like this. Okay, so it's going to look something like this. Not exactly, but this is enough to get to the answer. So if we think about where is the focus relative to the vertex, notice that they are on the same vertical axis. It doesn't matter if the parabola is smiling or frowning. Notice that the focus and the vertex of the parabola are on the same vertical axis, whether it's like this or like this. So that tells us that the x coordinate of the focus has to be -5. So these two answer choices are out. Another thing too is that the focus has to be above the vertex if the parabola is smiling like this and the directrix is under. So if we have a y value at -2, our focus has to be somewhere above. The y value has to be above -2. So that's why choice 1 would have to be our answer. If we go down to -4, this is no good. This would tell us the height of our directrix. Our directrix would be at y equals -4. So just understanding the concept and how to draw this out will get you to the correct answer. Before we move on, I want to look at one more equation. I'm going to say y equals plus or minus 1 over 4p and then x minus h squared plus k. So it's the vertex form of a quadratic, but instead of a, I have plus or minus 1 over 4p. We're going to go with plus 1 over 4p if the parabola is smiling and minus if it's frowning. And the meaning behind this, p tells us the distance from the vertex to the focus, okay? So that's what we mean by the value p. And it also tells us the distance from the vertex to the directrix, okay? So the p value shows up from here to here and from here to here. So if we look at the term in our equation over here, the 1 over 8, we would set that equal to 1 over 4p. So we have 1 over 4p is equal to 1 over 8. And what that tells us is that 4 times p is equal to 8. Our p value is equal to 2. So using that information, if I go back to the graph over here, so I'm just going to clear this out. What we had before was we had the sketch of the parabola based on its vertex, but the vertex went down to -2. And if we have a p value equal to 2, if we go up 2, that's going to bring us to 0. And if we go down 2, that's going to bring us to -4. So this tells us the location of the focus directly. Using that p value, our focus is going to be here up 2 units, which puts the focus at the location over here at -5, 0. Okay, and then over here for the directrix, it's 2 units below y equals -2. So the directrix equation would be y equals -4. But either way, we're getting choice 1. Question 17, given q of x and r of x, what is a solution of q of x equals r of x to the nearest 10th? For a question like this, we just go over to the y equals and we type in each function. So we have 2 log x for q of x, and then we have r of x is equal to x minus 2 to the third power. So we have x minus 2 to the third, and then minus 4. And we want to know when are these functions equal. So we press graph, and there's a lot going on here. I mean, we can trace the intersection this way, but we could just press zoom 6 just to make the graph look more normal. And now we'll press second trace number 5, and we're going to trace the intersection point. Okay, if we want to know when the functions are equal, we look for where do the graphs intersect. So I press enter 3 times, and then this is the x value we want. So when we're looking for the solution, we're looking for the x value at the point of intersection, and we're rounding to the nearest 10th. So we look in the tens place is a 7, to the right is a 2. So we're going to round down to x equals 3.7, and this matches up with choice 2. Question 18, the volume of a cardboard box can be modeled by v of x, which is the product of the length, width, and height x. If the length can be represented by L of x and the width can be represented by w of x, then which function represents v of x? So for this one here, what we're going to do is v of x equals length times width times height. So we're doing the length is 18 minus 2x. The width is 18 minus 2x as well. And the height is equal to x. So just looking at this here, choice 3 is definitely out because we have an x times x times x. It has to be at least x to the third. And if I look at this part, I could see that this answer choice is out because please don't ever do something like this. A common mistake when students do something like a plus b squared, they write a squared plus b squared. But don't ever do this. This is a very dangerous bear trap, okay? When you do a plus b squared, you're really doing this. And you're going to have an a squared plus b squared at the end, but you also have a times b is ab, and you have b times a is also the same thing as a times b. And then this works out to a squared plus 2ab plus b squared. So just looking at that, I could see that this answer choice is out because that's for students that do this, use this idea over here, but this is incorrect. And then if we look, choice 1 is very cruel. This would be if you multiply 18 minus 2x by 18 minus 2x, but you forget this very subtle detail over here, okay? The height is equal to x. Just know that volume is 3 dimensions, okay? So it needs to have that extra x at the end. You can't just do length times width because that would be area, not volume. So that's how I know choice 1 is out, and it's definitely choice 2. But of course, if we want to see this done properly, we could actually multiply this out. So I'm going to multiply these two first. I'm doing 18 times 18 is 324. And then we have 18 times negative 2x is negative 36x. And then negative 2x times 18 is also negative 36x. And then negative 2x times negative 2x is positive 4x squared. Okay, and this is all the stuff in the brackets, and we're multiplying all of that by x. So now we have in here 324. We combine these two to get minus 72x. We're just doing minus 36, minus 36. And then we have plus 4x squared. And then from here, we multiply everything by x. I'm just going to make space to block this off. So if we multiply everything by x, we have 324x minus 72x squared plus 4x to the third. Everything just gets bumped up a power of x. Okay, so I'm just going to make this a little neater. We have 4x to the third over here. And then they just write everything in standard form. So we have 4x to the third minus 72x squared stays in the middle, and then 324x goes to the end. So choice 2 is definitely our answer. Question 19, the expression here is equivalent to, and for this one, it really helps to know these two properties of exponents. When we do a to the b times a to the c, that's equal to a to the b plus c. And when I have a to the b over c, this is the same thing as the c root of a to the b power. So that's the two properties that we're going to use for this question. So first, we're going to multiply these two by adding their exponents. We have same bases, so we just add the exponents. We're going to have 8, we'll just make this neater. So 8 to the x over 2 plus x over 3. And I'll just clean that up. We have x over 2 plus x over 3. And for this one, you could just do it in the calculator 1/2 plus 1/3. And this is going to work out to 5 over 6. Okay, so if you just want to use the calculator, you just do this plus this and press math, enter, enter on the TI-84 plus CE, and it will turn that decimal into this fraction here. But if you want to do this by hand, what we would do is find common denominators. So I'd multiply this first fraction here. I'll just make a little space. So this first fraction, the x over 2, I would just multiply that one by 3 over 3. So we have times 3 over 3. And this one I multiply by 2 over 2. And then the result, we're going to have 8 to the x times 3 is 3x over 6 plus x times 2 is 2x over 3 times 2 is 6. And now I could add these because they have common denominators. So I have 8 to the 3x plus 2x is 5x, and we're over 6. So now I'm going to use this property over here. So I have power over root. So what I have here is the 6th root of 8 to the power 5x. And now I just scan the answer choices, and this is going to match up with choice 1. Question 20, if theta is an angle in standard position whose terminal side passes through the point -3, -4, which statement is true? So for this one, it really helps to know this. We have ASTC, which tells us all students take crack. No, what it really stands for is all, and then sine, and then I'll just abbreviate. I'll write sine like this, tangent and cosine. And what this means is that when we have an angle that terminates in quadrant 1, like let's say something like theta equals 30 degrees, if you plug this into any one of the trig functions, you're going to get a positive ratio. But if you plug in an angle like let's say theta equals 100, if you plug it into all of the trig functions, only sine and its reciprocal are going to give you something positive. And then same thing in this quadrant, if we have something like theta equals, let's say 220. If I plug that into all of the trig functions, only tangent and its reciprocal cotangent are going to give us something positive. And then finally, quadrant 4, if I had something like theta equals 300 degrees, I plug that into all the trig functions, only cosine and its reciprocal secant are going to give us something positive. So that's what this tells us here, but we remember ASTC. So that's what we need to answer this question. So when they tell us the point -3, -4, that throws us into quadrant 3. So we are here, okay? And if I want to spin here, what I'm doing is I'm starting from standard position and I'm spinning an angle of theta to get here. Okay, so that's the angle we're making to bring us here. So if I plug in a quadrant 3 angle into the trig functions, only tangent and its reciprocal cotangent are going to give us something positive. So right away, I could see the tangent at that angle has to be positive. So this answer choice and this one are out. But when we look at the remaining answer choices here, secant theta greater than 0, secant theta less than 0, we could look and say, all right, well, in this case, if I'm in quadrant 3, only tangent and its reciprocal are positive, so the other functions would be negative. So since secant theta is equal to 1 over cosine theta, this function is going to be less than 0 when we have, let me just write this out a little bit better. So this is going to be less than 0 when theta is in quadrant 3. Okay, so when it's in quadrant 3, 1 over cosine theta is going to be less than 0. So choice 1 is out. Choice 4 is going to be our answer. Question 21, what is the value of y for the system shown below? For this one, we could just use the calculator. We press apps and we go to number 9 over here. And I'm going to select simultaneous equation solver. So that's option 2. And we have 3 equations and we have 3 unknown variables. Okay, and we press graph so that we go next. And then from here, we just have to type this in. So 3x, I press 3, enter, and it makes the coefficient of x equal to 3. And then we have plus, so I'm just going to press enter, 4y. And then for this, I could either write subtract, or I could make my coefficient of z equal to -5. So I'm going to go minus, and then 5z like this, equals -27. Just make sure when you type in negatives, you use the negative sign. And when you want to subtract, you use this one. It's a very common thing that students mix those up, and then the calculator freaks out. So now the second equation is 2x plus, so I'm going to press enter, 3y, and then minus z, I'm just going to put a 1 in front. And this equals -3. And then for the last equation, we have 6x. So I have 6, enter. I could leave this as plus and then make my coefficient -1. So you could also type it in like this, or once again, you could just make that subtraction. And then I have plus 4z, and this one equals 3. And then you just press graph and it'll solve. So just using calculator magic, we get choice 3. The y value here is equal to 3. But now let's say we want to solve this by hand, because if this shows up in the free response, we would have to show all the work to get full credit. So I'm going to call this equation 1, equation 2, and this one equation 3. So if I was going to do this by hand, what I would do is I would look at which variable is easiest to eliminate first. And it looks like z is easiest to eliminate because the middle equation, equation 2, there's a -1 in front of the z. So I'm going to start off with, let's say, equation 1, where we have 3x plus 4y minus 5z equals -27. And then equation 2, I'm going to multiply this by -5. So I'm going to say -5 times equation 2. And this is going to give us, for the modified equation 2, we're going to have -10x. So I have minus 10x because I'm doing 2x times -5. I have 3y times -5 is -15y. And then I have -5 times z is plus 5z. And this is equal to -5 times -3 is 15. So I'm doing this so that when I add these equations together, the z terms eliminate. And now we have 3 minus 10 is -7. So we have -7x. And then this one here works out to -11y equals, and this would give us -12. So next, what I want to do is I want to eliminate the z in this equation. So I'm going to take equation 2, and this time I'm going to multiply it by 4. And that's going to give me 4 times 2x is 8x. And then we have plus 4 times 3y is 12y. And then 4 times minus z is -4z equals -3 times 4 is -12. So I'm just multiplying everything in this equation by 4. And then equation 3, I'm just going to copy. We have 6x minus y plus 4z is equal to 3. And now when I add these together, notice that the -4z plus 4z cancels. We have 14x plus 11y is equal to, and this gives us -9. And now from here, I could combine these two equations. So I'm going to write them over each other. We're going to have 14x plus 11y equals -9, and we have -7x minus 11y equals -12. And we could add these together, and the 11y minus 11y cancels. 14 minus 7 is 7, so we have 7x equals negative 21. And if we divide both sides by 7, x is equal to negative 3. And then once we have our x value here, we could plug into any one of these equations to solve for y. I'm going to plug into this one over here. So this one I plug in, we have negative 7 times negative 3 minus 11y equals negative 12. And this gives us 21 minus 11y equals negative 12. And then from here, I could just do the algebra. So I'm going to go minus 21 on both sides. And after this, we have minus 11y equals minus 33. And if we divide both sides by negative 11, y is equal to positive 3. Okay, so y equals 3 is definitely good. Choice 3 is our answer. Question 22, the number of employees who work nights and weekends at a department store is summarized in the table below. Let n represent the event works nights and let w represent the event works weekends. Based on the table, are n and w independent events? Now, before we get into the heavy math over here, first we could eliminate two answer choices just based on what it means to show two events are independent. So two events are independent if the probability of, let's say, n times the probability of w is equal to the probability of n and w occurring. So choice 1 is a contender, but choice 2 is out because we can't say yes and then the equation that we use to show independence is not holding true. Okay, so that's why 2 is out. And then if we were going to say no, these events here are not independent of each other, then it wouldn't be true for the probability of n times the probability of w to be equal to the probability of n and w. Okay, so these two answer choices are out, so it's going to be either 1 or 4. So now let's get into the math. And what I like to do for questions like this is find the totals. So we could do 8 plus 40 is 48. 12 plus 60 is 72. And then if I add these two, I get 120. And then if I go this way, 8 plus 12 is 20. 40 plus 60 is 100. And notice 20 plus 100 is also 120. Okay, so these values are definitely good. So now let's think, what is the probability of n? So we were told that n represents works nights. So if we look at the probability that someone will work nights, that's 20 people that work nights out of a total of 120 people. And this fraction reduces to 1 over 6. I could just cross off the common zeros here, and I could divide the top and bottom by 2. So now we'll find what is the probability of w. What is the probability that someone works weekends? And works weekends is going this way horizontally. So we could say 8 plus 40 is 48. That's 48 people out of, and I'll just make this neater. So we have 48 out of 120. And this I could reduce in the calculator. I could just press enter. I could divide these, press enter, and then math enter. Or I could just divide the top and bottom right now by 24. And this fraction reduces to 2 over 5. So now what I want to find is the probability of n times the probability of w. And this, we would get 1 over 6 times 2 over 5, and this works out to 2 over 30, which then I divide top and bottom by 2, reduces to 1 over 15. So we have to remember this number here. But now we're going to find the probability of n and w in the table. What is the probability that someone is going to work nights and weekends? So the people that work nights and weekends are the overlap of the work nights column and the work weekends row. And that's going to be this entry here. There are 8 people that work nights and work weekends. Okay. And that's 8 people out of the total 120. And if we divide the top and bottom by 8, notice we get 8 divided by 8 is 1. And 120 divided by 8 is 15. And notice 1 over 15 matches here and here. So the probability of n and w occurring is equal to 1 over 15, which is equal to the probability of n times the probability of w. So yes, these events are independent. Question 23, which expression is equivalent to x to the 8th minus y to the 8th? And for this one, the big idea is to use a squared minus b squared equals a plus b times a minus b. We have a difference of 2 squares, and when we factor, we do the square root of the first term plus or minus the square root of the second term. So I'm going to start this question off exactly that way. So I'm doing the square root of x to the 8th power. And the math that I do in my head, when I do the square root of x to the 8th power, I use that power over root idea, that the invisible root of square root is 2. So I'm doing x to the 8 over 2. And that becomes x to the 4th power. And it's the same idea for y to the 8th. So I have x to the 4th plus y to the 4th times x to the 4th minus y to the 4th. And what we have here is we have another difference of two perfect squares. So I could apply this concept again. So I'm going to go in the next line. We have x to the 4th plus y to the 4th. And then the highlighted stuff is going to break down into two binomials. We're going to have x squared plus y squared times x squared minus y squared. Okay, so that's how this stuff over here broke down into two binomials. And then we look and the answer is still not there. And that's because just one more time we could break this down. So we have x to the 4th plus y to the 4th. We have x squared plus y squared. But the difference of two squares over here could break down into these two binomials. We could call this x plus y times x minus y. And if we scan the answer choices, this is going to match up with choice 3. Question 24, a research assistant receives a first-year salary of $90,000 and a 2% annual raise throughout the first 10 years of employment. In total, how much money will be earned over the first 10 years to the nearest dollar? So for this question, we have to be very careful. It's very tempting to do 90,000 times 1 plus 2% is 0.02, and then raise this to the 10th power. If you do this and you round to the nearest whole number, you're going to get 109,709. And choice 2 is going to be waiting for you, but choice 2 is a very dangerous bear trap, okay? Read the question very carefully. The question is asking for how much money will be earned over the first 10 years. That means we have to add the amount of money the employee works for each of those years. So this is going to be a geometric series. So the formula we want to use is at the back of the Regents. That's S sub n. I'll just make this a little bit neater. We have S sub n equals A1 minus A1 times R to the n over 1 minus R. So for this one, we have to identify the R value. And the R value is the rate at which the salary is growing each year. So if we look, the 1.02 that we're getting here, remember 2% is 2 out of 100, and that's equal to 0.02. This part is definitely relevant, but that's our R value. That's R equals 1.02, okay? Because our geometric series here is growing by this amount each year. And now N is the number of years that this is going on for. So this is for 10 years. So what we're doing is we're adding their first year salary, second year, third year, fourth year, all the way to the end. So all we have to do is just plug in here. We have S sub 10 is equal to, and A1 represents the starting salary. So the starting salary is 90,000. And then for A2, if I had to find A2, I would take 90,000 and multiply it by 1.02. This would add the 2% on. A3, I would multiply by 1.02 again, and this would bring us to 1.02 squared. Okay, so you could do this all the way down to A10 and then just add all these numbers together, but that's going to take forever to type into the calculator. So they have this wonderful formula that will speed things up. So now A1 is 90,000 minus 90,000. So we're writing A1 again, times R is 1.02, and we're raising it up to the 10th power. And we divide all of this by 1 minus R is 1.02. And this we just type in the calculator. So for this one, I definitely want to press alpha y equals enter to pull up a blank fraction. And we have 90,000 minus, and then we have 90,000 again, this time multiplied by 1.02 to the power 10. And we're dividing all of this by 1 minus 1.02. Okay, we press enter, and here's our answer. So what we just found here was S sub 10. This is the sum of the first 10 terms. So here, we're rounding to the nearest whole number. In the ones place is a 4, to the right is an 8. So this would round up to, we would say 985, 475, and we'll see that this matches up with choice 4. Before we move on, I just want to look at a common sense solution. Okay, so using common sense, think about this. We're finding the total amount of money earned in the first 10 years. So let's say I take 90,000 and I multiply that by 10. That would be 900,000. Okay, so the person has to make more than 900,000 because they're getting raises. They're getting 2% raises. So these answer choices go away. right away because they're not even close to 900,000. This answer choice we could cross out because if we look, let's say they got no raises at all, then they would make exactly $900,000 in 10 years. They wouldn't make less than $900,000. So we could just use common sense to eliminate all the answer choices, and 4 would have to be our answer. So now we're moving on to part 2. There's 8 questions here, and each one is worth 2 credits. Question 25, on the set of axes below, graph this function. So let's go over to the y equals, and we'll type this in. We have 3.2 times, so we're putting parentheses, we have 1.8 as the base, and we're raising this up to the x power. So we press graph, and notice that we get this exponential curve here. And if we want to be extra precise, we press second graph to go to the table. And we're going to copy down some of these values. Now, what was a little annoying about this question is that we get really wacky decimals here. So we're just going to do our best to plot these points in the neighborhood. But I'm only going to be plotting a few points here. So let's say I'll go from -3 up to +1. So now that we have all of these points plotted, what we're going to do is connect them. But remember, we have a horizontal asymptote on the x-axis. And the curve is just going to keep going up and up like this as we go towards infinity in the x direction. So now we'll just connect. Question 26, is x plus 3 a factor of this polynomial? And we have to justify our answer. So the fastest way to do this question would be to plug in x equals -3 to this polynomial and see if it's equal to 0. Because if x plus 3 is a factor, when we set x plus 3 equal to 0, that would tell us x equals -3 would be a root. So all we have to do here is just plug in. We have 7 times -3 to the third plus 27 times -3 squared. And then we have plus 9 times -3 minus 27. So we'll go to the main screen here and we're going to type in. We have 7. Make sure you use parentheses. We have -3 in parentheses to the third. And then we have plus 27 times -3 to the second. So it's very, very, very important that you put parentheses here, because if you don't put parentheses around -3, you're going to get something different. So especially when you have even powers, you have to put your negative numbers in parentheses. And now we have plus 9 times -3, and then minus 27. And now, moment of truth, the expression here does work out to 0, so we can say that x plus 3 is a factor. So we could say that this expression is equal to 0, and that tells us that x plus 3 is a factor. Now, if we had to write a sentence, if we had to explain, then I would say since x equals -3 is a root, x plus 3 is a factor. But all we have to say here, is x plus 3 a factor? We'll say yes, x plus 3 is a factor of the polynomial. Question 27, over the set of integers, factor the expression here completely. So for this one, what we're going to do is factor by grouping. So I'm going to take out the greatest common factor, which is 2x to the third. And then I'm going to divide each of these terms by 2x to the third. And we're going to be left with x when we do 2x to the fourth over 2x to the third. And when we divide minus 10x to the third by 2x to the third, we're going to be left with minus 5. And now we repeat this for the next two terms. So we have the greatest common factor here is 3x. We divide each thing by 3x and we're left with x minus 5. So from here, we have a matching x minus 5. So we could say that this is equal to x minus 5 times 2x to the third and then plus 3x. Now from here, what we're going to do is we're going to take out the greatest common factor from this part. So we could take out an x and we're going to have x minus 5 times x. And when we divide each thing here by x, we're going to have 2x squared plus 3. And now this cannot be broken down anymore. If you want to rewrite this in this form here, you can put the x in front and say x times x minus 5 times 2x squared plus 3. But it would have been fine to stop at the previous line here. But either way, this will be our expression factored completely. Question 28, the monthly unemployment rate of towns in the United States is approximately normally distributed with a mean rate of 5.2% and a standard deviation of 1.6%. Determine the percentage of towns to the nearest integer that have a monthly unemployment rate greater than 6%. So for this one, this is all calculator work. We're going to press second vars, and we're going to go to number 2, normal CDF. And for this one, we have to think about the range here. So they're asking us to determine the percentage of towns that have a monthly unemployment rate greater than 6%. So our lower bound is going to be 6. Okay, we're going to make the lower bound 6, and then the upper bound is the maximum. So let's pretend that there was a 100% unemployment rate. So the upper would be 100 then. Okay, that's pretty much unrealistic. I mean, that would be the end of civilization if everybody was unemployed, but that's the idea. We can make the upper bound in this case as ridiculous as possible. And now we have the mean going here. The mean is 5.2. So we have 5.2. And then after this, we have the standard deviation is 1.6. Okay, and we press enter all the way through. And then this gives us the values that we need. Now, in terms of showing work, I would copy down exactly what I see in the calculator. But now we have to find the percentage to the nearest integer. Okay, so we're rounding to the nearest whole number, but when we want to convert this decimal to a percentage, we have to move the decimal 2 places to the right. So we go 1, 2 like this. So what I'm thinking of right now is we have 30.85, and I'll stop here because we have a 3, so I'm going to round down for now to just 30.85. But they want us to round our percentage to the nearest integer. So that's to the nearest whole number. So we're looking here at the 0, to the right is an 8. So we're going to round this up to 31%. Okay, so here is our solution to question 28. Question 29, the function d of t models the water depth in feet at a location in a bay t hours since the last high tide. Determine the minimum water depth of the location in feet and justify your answer. So for this one, the concept that we need to know is when we have a sine or cosine curve, the anatomy of the curve we could find by looking at the equation that they give us. So when I think of any sine or cosine curve, it looks something like this. And we have the midline is here. Okay, so the midline is going through the middle of the high and low point. So this is our midline. And what we also have is the amplitude is the distance from the midline to the high point or from the midline to a low point. So this is the amplitude. And when we're looking for the minimum water depth, we're looking for the low points here of our curve. So we're going to combine everything that we have in this picture to help us find that. But what we also need to know is that in the formula, we have something in the form of, let's say, y equals a cosine of bx, and then plus c. The a term is the amplitude, and the c term is the midline. So using that idea, this tells us that the amplitude, so we have the amplitude, in our case, is equal to 2. And the midline is going to be the line y equals 5. Okay, so this one I'm actually going to write out as y equals because that tells us where the midline is. So if I just sketch something over here, the midline at y equals 5 would be something like this. Okay, and then the maximum would be 2 units up from the midline. So that would go up to 7. This would be where the max is, at 7. So the minimum would be 2 units down from the midline. So if you do 5 minus 2, we get 3, and this is our minimum. So we have to determine the water depth of the location in feet and justify our answer. We're going to say that the minimum, so the minimum is equal to 3. Okay, so the minimum here is going to be equal to, we could say 3 feet. And if we need the justification here, we could say that it is the midline. So the midline minus the amplitude, okay, which I'll just abbreviate like this. So the midline minus the amplitude, and this would get us full credit for question 29. Question 30, a brewed cup of coffee contains 130 milligrams of caffeine. The half-life of caffeine in the bloodstream is 5.5 hours. Write a function c of t to represent the amount of caffeine in the bloodstream t hours after drinking 1 cup of coffee. So for this one, if you know how to just go from the question right to the equation, you'll get full credit here. So the initial amount goes in front. The 130 milligrams of caffeine goes in front. And since we're dealing with a half-life, we're going to be writing an exponent function here with the base of 1/2. And then the half-life time of 5.5 hours is going to go in the denominator. So we have over 5.5. So just setting this up here would get us full credit. Now, the kind of math that I do in my head is I say, okay, if 5.5 hours goes by, so something like 5.5, if I plug that in, so C of 5.5, that would give us 130 times 1/2. And if I do 5.5 over 5.5, that's equal to 1. And what that tells us is to take 130 and multiply it by 1/2 exactly once. Okay, which makes sense. If 5.5 hours goes by, we have half the amount of caffeine that we started with based on the info they gave us here. Okay, so this is how I know that this is checking out. Question 31, Marcus is a long distance walker. In one race, he walked 55 miles in T hours, and in another race, walked 65 miles in T plus 3 hours. His rates are shown in the equations below. Marcus walked at an equivalent rate R for each race. Determine the number of hours that each of the two races took. So for this one, since the rate was equivalent for both races, we could set these two equal to each other. We could say 55 over T is equal to 65 over T plus 3. And now from here, we just have to do the algebra. We could cross multiply. 65 times T is 65T. And now we could say this is equal to 55 times T is 55T. But then plus, when we do 55 times 3, that's going to give us 165. And now from here, we just subtract 55T on both sides. And let's see what we have next. So we have these terms canceling. We have 10T equals 165. And we divide both sides by 10. From here, this tells us T equals 16.5. But now we have to be very, very, very careful here. We have to determine the number of hours that each of the two races took. So the first race was T hours. So we could say that it's 16.5 hours for the first race. And we could say T plus 3, if we just do 16.5 plus 3, that's 19.5. So 16.5 hours and 19.5 hours. These are the times that it took for the two races. Question 32, we're going to solve this equation algebraically and express the answer in A plus BI form. So what they're telling us here is that this quadratic equation is going to have imaginary roots. So we could use the quadratic formula. And this formula, if you forget, is on the reference page in the back. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case here, we have an a value of 1. We have a b value of 3. And a c value of 11. So we plug in, we have x equals negative b gives us negative 3, plus or minus the square root of, we have 3 squared minus 4 times a times c, and we're dividing all of this by 2a. Now, notice I put the b term in parentheses before I squared it. And the reason I do that is because if b is negative, one of the most common mistakes I see is that students leave out the parentheses, and when they have a negative b, that it winds up staying negative when they square it, and it throws the whole question off. So just make sure you put your b term in parentheses before you square it, especially when it's negative. So here, now we have negative 3 plus or minus, and we have the square root of, we have 9 minus 44 all over 2. So we simplify a little bit more, and we have negative 3 plus or minus, and this is going to give us the square root of negative 35 all over 2. And now we could use properties of radicals. I'm going to rewrite this radical as the square root of negative 1 times the square root of 35 all over 2. And now we should know that the square root of negative 1 is I. So we have I times the square root of 35, and we are all over 2. But they told us to express the answer in A plus BI form. So we should actually split this up. We should say x equals negative 3 over 2 plus or minus, and then we have radical 35 times I over 2. Okay, so radical 35 times I over 2. Now, me personally, I like to write it like this separately. We can say I radical 35 over 2, but technically the question is asking us to write this in A plus BI form. So I like to write the coefficient of I in front like this so that it's truly in that form. If you don't do that, they're not going to take off points. But once again, if the question is asking for something, I like to write the answer exactly as they ask for it. That way, there's no chance of them taking off points. So now we're moving on to part 3. There's 4 questions here, and each one is worth 4 credits. Question 33, the population of China in millions can be modeled by the function p of x, where x is the number of years since 1900. The population of India since 1900 is summarized in the table below. And we want to know which country's population had a greater average rate of change between 1950 and 2020. And we have to justify our answer. So for this one, we have to know that average rate of change is f of b minus f of a over b minus a. Okay, and this is when we're finding, let's say, the average rate of change, which we'll abbreviate like this. The average rate of change of f of x on the interval ab, then we use this formula. So when we want to find the average rate of change for the population of China from 1950 to 2020, what we're going to do is we're going to do P of, so this is for China, we'll just say over here. So for China, we're going to do P of, and be very careful here. We're going in 2020, and X is the number of years since 1900. So 2020 is 120 years after 1900. So that's P of 120. And then minus 1950 is 50 years after 1900. So that's P of 120 minus P of 50. And we divide by 120 minus 50. When we have to do this for India a moment later, here we could just grab the values from the table. So we have these values here that we would use. So for this question, I'm going to go over to the y equals, and I'll type in 316.93. And then E is second ln. And we have e to the power 0.0133 times x. And what I'm going to do is I'm going to go back to the main screen. I'm going to press alpha y equals enter. And our goal is to find P of 120 minus P of 50. So P of x I wrote in the y1 spot. So here's a nice trick. We could press alpha trace to pull up y1. And I'm going to do y1 parentheses 120. And this tells the calculator to evaluate the function at 120. And then I'm going to go minus, and we have alpha trace. If you have an older calculator, you could press vars and go to the right and go to function, and you could find y1 over there as well. Okay, but the newer TIs, you can just do alpha trace and get right to y1. And I'm going to type in 50, and we are dividing by 120 minus 50. Okay, so I could just type this in directly. So this is for the average rate of change in the population of China. So now for India, I'll just do this all at once. We're going to be doing the difference of the y values over the difference of the x values. So I'm going to press alpha y equals enter. And we're doing 1380. So we have 1380. And then minus 376.6. And we're dividing this by 120 minus 50. Okay, so we're just typing in for India as well. And then we just have to compare which one is greater. Now, one other thing I want to point out, let's say you don't want to use this shortcut here. You could also go to the y equals, and we go to second graph to pull up the table. And we have these values here, but what we could do is press second window and switch the table from auto to ask. And what that allows you to do is you can make a custom table. So I could also type in 50 and 120, and then I would be able to write these values out myself. So I would have this y value minus this y value for the function p of x. So for China's average rate of change, we'll round this to 13.53. Okay, I'll stop at 2 decimal places. And then for India, what we're going to do is we actually have to show the work here. So for India, let's think about what we found in the calculator. We did the difference of the y values over the difference of the x values when we were at x equals 50 and 120. So here I just write that out. We have 1380 minus 376.6. And we're dividing this by 120 minus 50. And this is equal to, we round to 14.33. So now we just have to make the observation, which country had a greater average rate of change between 1950 and 2020? It would be India. In a packaging plant, a machine packs boxes with jars. The machine's manufacturer states that a box is packed on average every 42 seconds. To test that claim, the packaging plant randomly selects a sample of 10 boxes and finds the sample mean to be 49.8 seconds. The company ran a simulation of 1,000 trials based on the manufacturer's claim, and the approximately normal results are shown below. And then we have, based on the simulation, determine an interval containing the middle 95% of plausible mean times and round your answer to the nearest hundredth. So to find the middle 95% interval, you're taking the mean and you're going to go plus or minus 2 standard deviations. So we could just go over to the calculator, and the mean, we have 42.029. And we're going to go plus or minus. The standard deviation is 3.105, but we're going plus or minus 2 standard deviations. So that's 2 times 3.105. Okay, so this is for the upper end of the interval. And then for the lower end of the interval, we're going to go minus 2 standard deviations. So I just go up to this expression. I press enter to copy it, and I just switch the plus to minus. And this gives us the values we need. So now we'll just record this. We have 42.029, that's our mean, and we have plus or minus 2 standard deviations. The standard deviation is 3.105. And the answer, we're going to round to the nearest hundredth, okay? So when we write the results in the interval here, we're going to round to the nearest hundredth. So the lower end is going to be 35 point, and then in the hundredths place is a 1. To the right is a 9, so we're going to round to 35.82. And for the upper end, we have a 3 here. To the right is a 9, so we're going to round that one to 48.24. So here is our interval containing the middle 95%. So now for the last part, is the time 49.8 seconds unusual? And we have to use statistical evidence to justify our answer. So if you want to determine if something is reasonable or unusual, you have to see if it falls within the middle 95% interval. So we look at 49.8, and this is not on this interval. 49.8 is greater than 48.24. So it's not in the interval, so that tells us that this time is unusual. Question 35, consider the function f of x, and is f of x an even function? We have to justify our answer. So the formal way to show this would be to see if f of x is equal to f of negative x, okay? This is the textbook definition for even functions. And this could be a little bit tricky to understand. So what I like to do is look at the visual representation. So if I were to sketch out f of x is an exponential function and it's growing. So it looks something like this. And if the graph of your function has y-axis symmetry, then your function is even. So notice that we do not have y-axis symmetry here. So f of x is not an even function. Okay, if I had something like, let's say y equals x squared, I could draw like this, and this definitely has y-axis symmetry. So that's why x squared is an even function. But now to use that textbook definition, we have f of x is equal to 2 to the x. We have f of negative x. This would be equal to 2 to the negative x. I just replaced the x's with minus x. And this, I could use properties of exponents. I could flip the base or find the reciprocal and call it 1/2, and then that allows me to make the power positive. So now when we look at this, 2 to the x is not the same function as 1/2 to the x. They only match when x is equal to 0. Okay, that would be the only time that they would match. But otherwise, they do not match for all x. Okay, so these, I'm just going to comment here, these are not equal. Okay, these are not equal for all x. Okay, so this is not true for all x. So then what does that allow us to say? It allows us to say f of x is not an even function. Oh, and just in case you haven't seen this notation before, the 3 dots in this triangular formation mean therefore. So this answers the first part. Now for the next part, we want to write an equation for g of x, the function that results after f of x is shifted up 5 units. So g of x is going to shift f of x up 5 units. So that means we're going to take f of x and we're going to add 5 to it. So then we could say g of x is equal to f of x is 2 to the x power, and then we tack on the plus 5 at the end like this. Okay, so this would be our function for g of x. And now for the last part, we're going to write an equation for h of x, the inverse of g of x. So when you want to find an inverse function, you switch the x's and y's, and then you solve for y. So what I'm imagining is our function g of x. Remember, we could say things like y equals g of x, but I imagine this function is expressed as y equals 2 to the x plus 5, because then it's more obvious how to switch x and y. So we could say x equals 2 to the y power plus 5. So we could start by going minus 5 on both sides. So we get here, and now we have x minus 5 is equal to 2 to the y power. Now, there's a few ways that we could solve for y here, but one way is to make use of the idea that when we have log base a of something like this, like log base a of a, that's going to be equal to 1. So the move that I want to do is I want to take the log base 2 of both sides because the base of my exponent is 2. So that's why I want to take the log of a matching base to my exponent so I could use this property here. Okay, so that's what we're going to do next. So we have log base 2 of x minus 5 is equal to log base 2 of 2 to the y power. Now, there's another property of logs that says when we have log base a of, let's say, b to the c power, this, I could take the exponent in the log and bring it to the front and say c times log base a of b. So that's what I'm going to do with the y term here. I'm going to bring this to the front, and we're going to have log base 2 of x minus 5 equals the y comes to the front, and we have y times log base 2 of 2. But here's this property. We have log base 2 of 2. The base matches the inside term. So that's just going to be equal to 1. This is basically just going to cancel out. And we could say that y is equal to log base 2 of x minus 5. But now, just to answer this formally, I'm going to write an equation for h of x. So I'm just going to say over here, h of x is equal to log base 2 of x minus 5. And here is our solution to the last part. Question 36, we're going to solve the system of equations shown below algebraically. So for this system, I want to solve it by substitution. I'm going to take that second equation and I'm going to solve it for x. So I'm going to go plus y on both sides. And now we have x equals y plus 6. And this I'm going to plug into the other equation. So I'm going to replace this x with y plus 6. So now we plug in and we have y plus 6 minus 4 squared. So just so we're clear, this x I replace with y plus 6 because of what we found before. And then we have plus y minus 1 squared is equal to 9. Now, one thing to be careful of, please don't do something like this. A common mistake is students have something like this and they think, oh, a plus b squared equals a squared plus b squared. Please don't actually do this because you will get the wrong answer if you do the algebra this way. So instead, we're going to have, let's see, y plus 6 minus 4 is 2. So we have y plus 2 squared plus y minus 1 squared equals 9. And for this, I'm actually going to expand it. So I'm going to write this out. I'll just draw the progression over here as y plus 2 times y plus 2, and then plus y minus 1 times y minus 1 equals 9. And then from here, we do the algebra. We have y times y is y squared. Then we have y times 2 is 2y plus another 2y plus 4 when we distribute to the end like this. And now we have y times y is y squared. We have minus y minus another y, and then plus 1, and this equals 9. So now we just have to simplify very carefully. So let's see what we get. We have 2y plus 2y is 4y, and then we have minus y is minus 2y, and 4y minus 2y is going to give us 2y. We also can combine the y squared terms. We have a y squared here and a y squared here, so that's 2y squares. And then for the constants, we have 4 plus 1 is 5. So we have plus 5, and this is equal to 9. So from here, what we could do is we could subtract 9 on both sides. And at this step, 9 minus 9 cancels. We have 2y squared plus 2y, and then we have 5 minus 9 is minus 4, and this is equal to 0. So from here, we're going to factor this quadratic. So I could take out a 2 first, and we'll have y squared plus y minus 2 equals 0. And now we have to think two numbers that have a sum of 1 and a product of negative 2. And the two numbers that work here are going to be y, we have plus 2, and y minus 1, because 2 plus negative 1 is 1, and 2 times negative 1 is negative 2, and this is all equal to 0. So now I would set the non-constant factors equal to 0. So if we set y plus 2 equal to 0, this gives us a root of y equals negative 2. And when we set y minus 1 equal to 0, this gives us a root of y equals 1. So now we could plug these y values in to find the corresponding x values. So when y is equal to negative 2, I'll plug into this x equals equation over here. We would have x equals negative 2 plus 6, which gives us positive 4. So this will give us our first solution. And then for our second solution, we have y equals 1, would give us x equals 1 plus 6. So I'm just plugging in for y, and this gives us x equals 7. But remember, please write out your solutions formally as an ordered pair. So for the first solution here, we have x is 4 and y is negative 2. And then we have x is 7 and y is 1. So these are the solutions to the system. Now, one thing you could do before you move on is check. So we could plug these values in and see if they work out. So for the check, I'll just write this over here. What we have is 4 for x, y is negative 2. So I have 4 minus 4 squared, and then plus y is negative 2. So we have negative 2 minus 1 squared. And let's see if this is equal to 9. Well, this is just equal to 0, so it cancels out. And negative 3 squared is, in fact, equal to 9. So this point checks out here. And if I do 4 minus negative 2, that is equal to 6. So this first point is definitely a solution. And now for the next one, if I plug in x is 7, y is 1, now I have 7 minus 4 squared plus 1 minus 1 squared equals 9. And then this term cancels out this time, 1 minus 1. And this gives me 3 squared is equal to 9, which is also true. So that second point is good. And if I plug in 7 minus 1 is also equal to 6. So these two solutions check out. So now we're moving on to part 4, the final boss. And this question is worth 6 credits. Question 37, Taylor wants to open an investment account with the $1,200 she received for her birthday. She has narrowed her choices down to 2 banks. America's Bank offers 6.4% annual interest compounded quarterly. Barnyard Bank offers 6.35% annual interest compounded continuously. Write functions for AFT and BFT to represent the value of her investment with America's Bank and Barnyard Bank as a function of time t in years. For this question, we have to know these two formulas. We have to know A equals P times 1 plus R over N to the NT power. We use this formula when we have compound interest, and the interest is compounding n times per year. So this could be for monthly compounding, compounded quarterly, semi-annually. We would use this formula. And we also have to know this formula over here. We have A equals PE to the RT power. So this is when we have interest that is compounding continuously. So for AFT, we're going to write this out. We have P is the principal value. The initial investment is $1,200. And we're multiplying by 1 plus R. The interest rate for America's Bank is 6.4%. So if we do 6.4%, that's 6.4 out of 100. And that's 0.064. So that's our interest rate for the Bank of, or America's Bank. And we're dividing that by the number of times we're compounding per year. Quarterly means we're going to be compounding 4 times per year. So that's n equals 4. Okay, so we're going to divide this by 4 and raise this to the 4t power. And then for BFT, we're going to have A equals, so we have this formula we're using here. P is the principal value. The initial investment is $1,200 times E to the, and this time around we have a 6.35% interest rate. So we do 6.35 out of 100, and that's 0.0635. Okay, so that's our interest rate for the second bank here. Okay, so we're just going to use this one. I'll just move this over so we could see it. So this is what's going to be plugged in to the formula here, to the RT. So we have to the 0.0635 times T. And what I'll do is I'll just simplify this part in A of T. So you could just type 1 plus this fraction here into a calculator, and that's going to tell us the base of our exponent. And I'll just make a little space so we can write the two functions next to each other. We have A of T is equal to 1,200 times, and when we work this out in a calculator, we're going to get 1.016, and this is being raised to the 4t power. So here are the two functions we need for the first part of this question. For the second part of this question, Taylor would like to invest the $1,200 into one bank for 10 years, making no additional deposits and no withdrawals. With which bank will Taylor earn the most money? And we have to justify our answer. So for this one, we should plug in T equals 10 into A of T and B of T and see which one gives us the greater amount. So let's plug 10 into A of T. We have 1,200, and then we have 1.016 to the power 4 times T, and T is equal to 10. We'll pretend we don't know 4 times 10 is 40. We're just going to plug it in as is, and we get this value here. And now we're going to do the same thing for B of T. We plug in T equals 10. So we have 1,200 E is second ln, and we have 0.0635 times 10. Okay, we're plugging in t equals 10. And now here's our results. Let's round these values to the nearest cent. So we're going to go over to the hundredths place, and we have a 7 over here. To the right is a 7, so we're going to round a of 10 to 2264.28. And for the next value, for b of 10, we have a 2 in the hundredths place, and to the right is a 6, so we're going to round this up to 2264.43. And now we just have to make an observation here. We could say that b of 10 is greater than a of 10. So the question is, with which bank will Taylor earn the most money? We could say Barnyard Bank, because b of 10 is greater than a of 10. And now for the last part of this question, Taylor chooses to invest her money in Barnyard Bank. Algebraically determine how long to the nearest tenth of a year it will take her initial investment to triple, assuming she makes no deposits or withdrawals. So remember from before, b of t is equal to 1200 times e to the 0.0635t. Okay, so this is the function for b of t, which represents how much money she'll make with Barnyard Bank. So if her goal is to triple her initial investment, then we're going to take 1200, that's the initial investment, and triple it, or multiply it by 3. So that's 3600. So we're going to set b of t equal to 3600. And now what we're going to do is solve for the variable t. We want to know, when does this happen? So now we just have to do the algebra. So we could divide both sides by 1200. And on the right side, 1200 over 1200 cancels. On the left side, this works out to 3 equals, and then we have e to the 0.0635t. Now from here, we have to get t by itself, so we do the opposite of e, which is natural log. So we take the natural log of the left side, and we take the natural log of the right side. Natural log and e are opposites, so they just cancel out. And we have natural log of 3 is equal to 0.0635t. Okay, so that's what we're left with here. I don't have to write parentheses here. I only did it because I wrote parentheses on this side. When it's just natural log of a single term, you can get away with just writing the single term like this without the parentheses. But if you write it, it's not wrong. Once again, I save it for situations like this when there's a lot going on. So now from here, to solve for t, we just divide both sides by 0.0635. Okay, so I'm going to do this on both sides, and this will tell us what the value of t is. So we could type in, we have natural log of 3, and we close the parentheses, and we're dividing by, we have 0.0635. So we're rounding to the nearest tenth of a year. So we look at the calculator value here. In the tenths place is a 3. To the right is a 0. So we would round down to 17.3. So it's going to take 17.3 years for Taylor's investment to triple.